Today we're going to talk about operating on functions, or you could say that we're going to use mathematical operations when I'm already given a couple of functions. In ninth grade you learned function notation. Just a super quick reminder of what function notation is. You simply replaced the variable y with f of x. You had to have an equation where y was isolated, or in other words, y was on one side of your equation and everything else was on the other side. And then you could just replace y with an f of x and boom, you're in function notation. You don't only have to use f of x when you write function notation. I could use g of x, h of x, j of x, m of x. I can use nearly any letter, and I say nearly because you wouldn't want to, for instance, say x of x. That wouldn't really make any sense. You can use mathematical operations on functions. Mathematical operations are add, subtract, multiply, and divide. So we're going to start today with some that you've done before, and we're going to add one today that you have not seen before. We're going to start with addition. So here I have three different functions, f, g, and h. What do you think f of x plus g of x would look like? What is it exactly that it's asking us to do? Well, in this case, remember it was simply taking what f of x was equal to and what g of x was equal to and add them together. So in addition, this is just a matter of combining like terms. So I can add 2x to another x and get 3x's. And I can add 4 and negative 3 and get a positive 1. So f of x plus g of x is 3x plus 1. How about f of x plus h of x? What is it exactly that it's asking us to do? Well, it's asking us to take what f of x is equal to and what h of x is equal to and now combine them together, or combine like terms. I'm going to start with the term with the highest exponent, so I'm going to start with that 3x squared. It doesn't have any like terms. There are no other x squareds, so I leave it be in my equation. I have two x terms that I can combine, two x's, and I'm adding 7 more x's, give me 9 x's. And I only have one constant, so I'm going to put the plus 4 at the end of my answer. So f of x plus h of x is going to be a positive 3x squared, a positive 9x, and a positive 4. In subtraction, subtraction was almost the same. There was just one more little thing we needed to do. This is asking us to subtract h of x and g of x, right? Take what h of x is equal to and subtract what g of x is equal to. But remember, in subtraction, this is simply subtracting polynomials, which we've already done this year. You have to distribute that subtraction through the second set of parentheses since you're subtracting everything there. So I'm not only just subtracting that x, I'm also subtracting a negative 3, which then is the equivalent of adding 3. So then when I combine like terms, I'm going to start with that 3x squared. There's no other x squared terms, so I leave it be. I have 7 x's, and I'm taking away one of those x's, so now I have 6 x's remaining, and the plus 3 on the end. So h of x minus g of x is 3x squared plus 6x plus 3. Multiplication is the same as you've seen before when we multiplied polynomials. If I have those same three functions and it asks me to multiply g of x and h of x, I write down what the two functions are equal to, and then I'm going to do my distribution. X distributed to the 3x squared gives me 3x to the third power. X times 7x gives me 7x squared. Negative 3 times 3x gives me negative 9x squared. And negative 3 times 7x is negative 21x. After I get all of my distribution done, remember we can combine like terms again. The 7x squared and the negative 9x squared can combine to give me negative 2x squared. So I end up with 3x to the third minus 2x squared minus 21x. And now here we go with our new one. We're going to add some division in here. So here I have two functions, f of x and g of x. We're actually not going to be doing all of the division today. We're just going to be doing certain types of division that will kind of build on the factoring you did last time. So if I'm asked to divide f of x by g of x, I'm going to write my two functions in that same order. And now comes the different part. If you look at the numerator of this fraction, our function x squared plus 2x minus 15, that's a quadratic equation that I can factor. So today we're going to focus on division problems where I can factor the numerator. In that case, we're going to look for factors of negative 15. I've listed all the factors of negative 15. Remember to include positive and negative numbers. Which one of these pairs adds to positive 2? In this case, the negative 3 and the 5, right? So I'm going to use the negative 3 and the positive 5 as factors for the numerator of my fraction. I'm going to split into x minus 3 times x plus 5, and of course x plus 5 is still my denominator. Since I factored the numerator of this fraction, remember back when you were doing exponents, right? You would write out all the x's in the numerator of your fraction and in the denominator, and then some of them would cancel. Well, we're going to be able to cancel some of these factors. If I have a matching factor in the numerator and denominator of my fraction, like here we have x plus 5 and x plus 5, those two factors can actually cancel each other out of the picture. They don't actually disappear. X plus 5 over x plus 5 just reduces to 1, but when I multiply something by 1, it's not really going to be helpful and it's not going to change my answer. So I'm only going to be left with the x minus 3. And that will be the answer to my division problem. Let's take a look at another one. Here I have two functions, j and k, and I'm asked to divide j of x by k of x. So I'm going to write down my two functions, and now the top part or numerator of my fraction can be factored. So I'm going to look for all those factors of positive 6. Remember to include positive and negative factors. And I'm going to be looking for which of those pairs adds to the positive 5 in the middle of my top function. In this case, the 2 and the 3. So I'm going to use the 2 and the 3, the positive 2 and positive 3 anyway, to break my numerator up into its factors. Notice how I have a matching factor in my numerator and denominator. Those two factors will cancel, and I'll be left with just x plus 2. So that x plus 2 will be my solution to my division problem. One last thing, sometimes the notation will look a little different depending on which book or worksheet or author or teacher you're dealing with. So just FYI, f of x plus g of x can look a little different. F plus g of x means the same thing. It says to take functions f and g and add them together. Same thing with subtraction. F of x minus g of x can look like f minus g of x. It means exactly the same thing. Same things with multiplication. F times g of x means the same as f of x times g of x. And finally division. F divided by g of x means the same as f of x divided by g of x. Just thought I'd throw that out there. Your worksheet will actually have both notations on there, so you'll need to know what both notations mean to do. Make sure you're writing down any questions that you have. Go back and pause the video and write down the examples so that you can have them in your notes in class. And have a great day.